humidity. So when we thought of the blue roof concept, we were literally looking out of our 11th floor window and seeing just what, seemingly flat roofs all over. We were basically surrounded by them, and so we wanted to find ways or see if there was ways to use the rooftops but at a cheaper cost than green roofs. And so we developed, basically, we tested an existing technology, the modified inlet, basically a roof drain, a controlled flow roof drain. And then we wanted to test some variations on that theme. So the check dams in the lower left are basically to build out bigger reservoirs across the whole roof surface. And then we followed that concept, but we wanted to include some geotextile fabric to slow down the flow. And so that's when we used trays. And these are literally 20 by 20 inch cake pans with holes drilled at the bottom, but laid with geotextile fabric to slow the flow out of those orifices. And then the ballast is really just to hold those down. So none of these installations across this, it's about a 20,000 square foot roof, none of these installations required any permanent modification to the roof and can be removed at any time, and that was important for this pilot. I'm going to show a lot of data charts and plots, so bear with me. There's one that I'll really focus on, but just wanted to show different ways that we showed the data or looked at the data. We definitely looked at specific storms. So here you see a 1.3-inch storm in 2012, and we looked to see, exactly what was happening on the rooftop as far as the peaks and the intensity, because we wanted to understand that along with the stormwater retention and peak flow reductions. But what you see here, the red is the uncontrolled quadrant, and what you see here is each of the modified quadrants and how it compares. So the modified inlet, really isn't doing much